everyone, this is Miss Sarika and I'm coming at you with another video. In this video, I am solving question 3 from assignment 2 for the 8th graders. Again, this is from assignment 2 for the 8th graders and we are working on question 3. So in questions 1 and 2, we were solving the system of equations by graphing. In question 3, we are trying to find if this coordinate point 2, 5 is a solution to this system of equations. So if you see a problem like this, and you're trying to find out if it's a solution to this system of equations, all you have to do is plug in the x value for x and the y value for y, and you can find out if the equation is equal. And if it's not equal, if one side of the equation is not equal to the other side of equation, then it is not a solution. But if for both equations are balanced, then it is a solution. So let me show you. So remember, this coordinate 2, 5, this is 2 is the x value and 5 is the y value, because remember, coordinates always go x and then y. So we're saying x equals 2 and y equals 5. Well, I can plug in this 2 for x and I can plug in this 5 for y. So 3x is the same thing now as 3 times 2 plus 17y, which is 17 times 5, equals 6. So if, for it to be a solution, for 2, 5 to be a solution, we'd have to find that the equations are balanced. So 3 times 2 is 6, plus 17 times 5, well, 10 times 5 is 50, 7 times 5 is 35, 85 equals 6. So 6 plus 85 is 91. Does 91 equal 6? It does not. And just let's be super sure just to check. So already this should be thinking it's not a solution because 91 does not equal 6. But let's plug in x and y into the second equation and see if it's balanced, just to make sure that we didn't make a mistake. So I plug in 2 for x over here and I plug in 5 for y over here. Well, 6 times 2 plus 5 equals 15. 6 times 2 is 12, plus 5 equals 15. Does 17 equal 15? No. So we were able to prove that 2, 5 is not the solution to this system because the equations aren't balanced. If the equations were balanced, then it would be a solution, and both equations would be balanced. Let me show you just another example of how to do this. I'm just turning it over. So again, is 0, 0 a solution to this system? So to find out if 0, 0 is a solution to this system, I would plug again in 0 for x and 0 for y, because again, this coordinate is x, y, which means that x equals 0 and y equals 0. I can plug into the equation and I will find out if they're true. If I plug in 0 for x in the first equation and I plug in 0 for y, does it equal 5? And if it did equal 5, it would be a solution. If it doesn't, it's not a solution. 2 times 0 plus 2 times 0 equals 5. Well, 2 times 0 is 0. Any number times 0 is 0. 2 times 0 is 0. Again, any number times 0. 0 does not equal 5. It's not possible. So already we know that this does not make the system true. So then let me try it in this equation. I would plug in 0 for x and 0 for y. So 0 plus 3 times 0 equals 0. Well, 0 does equal 0, but the point would have to work for both equations. It can't just work for one equation. So this is not a solution. We could